Alright, so this brings us to the icing on the cake. That's what one of my colleagues calls this. Factorising after you've done the product rule when you're doing differentiation. So you should remember that the product rule is f dash x is equal to uv dash plus vu dash. Now, because you've got something plus something else, the something and the something might have a common factor, and if they do have common factors, you've got to factorise those things just to make your maths nice and pretty at the end. You'll see what I mean right now. Alright, so I'm going to jump in the middle. I said after the product rule. So I've already done the product rule on a derivative, and I've found the derivative is this big long thing here. And a lot of students will go, yep, I used the product rule, I put it into the formula, and I'm finished. But there's actually a lot of work to go because we need you to factorise it at the end. So we have something, this is our something, plus something else, and we need to look for common factors here. So this says 4 times this to the power of 7, and this says 4x times this to the power of 6. And you should note a couple of common factors here. So this is 4 times that, and this is 4 times x times that. So we have a common factor which we can bring on the outside, and that common factor is the number 4. So there's our first common factor. Tick, tick. Our next common factor, if you look here, let's use a different colour maybe. If you look here inside these brackets, we have x squared plus 2x. Here we have x squared plus 2x to the power of 7, and here we have x squared plus 2x to the power of 6. Now, this is 1 power higher than this one. So the common factor that they both share is x squared plus 2x to the power of 6. Because x squared plus 2x to the power of 7 is the same as x squared plus 2x to the power of 6 times x squared plus 2x. So take the lower power. So our next common factor is going to be x squared plus 2x to the power of 6. So there's our common factor. As far as I can tell, there's no other common factors here at the moment. And now, I like to use like a big square bracket for now. You've got to ask yourself, this times what makes this? Alright, so there's a 4 here and here, so we don't need to multiply by 4. There's x squared plus 2x to the power of 6 here. There's x squared plus 2x to the power of 7, so there's 1 above that. So we need to put in another x squared plus 2x. Alright, I might just put that in brackets. Those brackets might not be necessary. Alright, so this times that is equal to that. So there's our first part. And now we need to ask this times what makes this. Alright, so we pulled the 4 out, and we pulled out the x squared plus 2x to the 6, and that's what's there. The stuff that's left over is this thing, the x, and this thing, the 4x plus 1. Okay, so, recapping, if we multiply all of that by that, we'll get that, and if we multiply all of that by that, this is the distributive law, we'll get all of that. Alright, so there's a little bit of factorising. Now, let's work inside of this bracket to neaten it up a little bit. X squared plus 2x to the power of 6. That pen's a bit squeaky. I don't really need that square bracket in there. And I don't really need these in a bracket because they're not being multiplied by anything. So, I can just do bracket x squared plus 2x. So they don't need to be in that bracket. Plus, and I'll use my distributive law here to write 4x squared plus x times 1, which is x. Okay, 4 times that, and then all of this. And I can group some like terms in there. 4 bracket x squared plus 2x to the power of 6 bracket x squared plus 4x squared is 5x squared plus 2x plus x, oops, that's 3x. Alright, we're looking pretty good there. Just need to take a look at what else we can sort of pull out of our brackets. Now, here, you can see a common factor because x squared and 2x, they have a common factor of x, but that x is being raised to the power of 6. So if I just drew this here, if you've got x squared plus 2x, the common factor is just x. But if you've got x squared plus 2x to the power of 6, then the common factor that comes out the front is x to the 6, and that's also raised to the power of 6. Alright, so I can move 4, and then I can take x to the 6 out, and that's going to leave me with x plus 2 to the power of 6. And then here, you can see that in this bracket I have a common factor as well. I have x's. Now we're not raised to a power here, so the x can just come out. 5x plus 3. And now, I promise this is the last step, I think. That x to the 6 and that x, it's 4 times x to the 6 times this bracket times x. So we can do x to the 6 times x, and that's going to be x to the 7. So I can move that to the front. So we started, well, first we differentiated something, that's way up there somewhere, and we got that as our answer, and then we factorised it to get to that as a final answer. That's probably not the most efficient way to factorise it. I sort of wanted to step through it step by step by step. The basic principles, though, are the same basic principles that you learnt all the way back in probably year 7 or so, and that is if there is a common factor plus 2x squared plus x, then you can take that common factor out. Just on a bigger scale. Alright, that's the icing on the cake, factorising after the product rule.